Stacks are interview catnip. Evaluate reverse Polish notation, RPN. Looks tiny, but it reveals whether you truly understand order of operations and data structures. Phone screens love it because one clean stack pass solves everything. No parentheses panic, no precedence chaos. Let's crush it with basic and finish with rock-solid, production-ready code. We're given a list of tokens representing an arithmetic expression in postfix form. Operands are integers. Operators are plus, slash. Evaluate the expression and return an integer, with division truncating towards 0. RPN is tailor-made for a stack. Scan left to right, push numbers. When we see an operator, pop the last two operands, write operand first, apply the operator, and push the result. Single pass, ON time, ON worst case space. Watch the Python gotcha. Integer division must truncate towards 0, use int a, b, not a / b. Plan. Create stack equals. For each token t, if t is an operator, pop b, then a, compute a, t, b, push result. Else, push in t. At the end, top of stack is the result. Let's try to implement it using solution 1. Line highlighted. Class solution. We define a solution class, the standard structure LeetCode expects. Pause. Line highlighted. Def eval RPN self, tokens. This method evaluates an expression written in reverse Polish notation, RPN. Pause. Line highlighted. Stack equals. We create a stack to store numbers and intermediate results. Pause. Line highlighted. For token in tokens, we iterate through each token from left to right. Pause. Line highlighted. If token not in plus / if the token isn't an operator, it must be a number. Pause. Line highlighted. Stack.into token. We convert it to an integer and push it onto the stack. Pause. Line highlighted. Else, otherwise, the token is an operator and we need to compute a result. Pause. Line highlighted. B equals stack.pop. We pop the second operand. Pause. Line highlighted. A equals stack.pop. And then the first operand. Pause. Line highlighted. Operator checks, plus, / we apply the correct operation to A and B. Pause. Line highlighted. Stack.append result. We push the computed value back onto the stack. Pause. Line highlighted. Return stack 0. When all tokens are processed, the final answer is the only value left on the stack. Pause. And that's how the algorithm works. It scans tokens, pushes numbers, applies operations when needed, and leaves the final evaluated value on the stack. Efficient, simple, and elegant. Highlight input box. Tokens equals 2, 1, plus 3. Let's test our function using this input. 2, 1, plus 3. These tokens represent an arithmetic expression written in reverse Polish notation, RPN, where the operators come after the numbers. Left magnifying glass emoji, what the input represents in RPN. Numbers get pushed onto the stack. When an operator appears, it applies to the two most recent numbers on the stack. So the expression here is push 2. Push 1. Apply plus compute 2 plus 1 equals 3. Push 3. Apply compute 3 times 3 equals 9. This is equivalent to the normal infix expression. 2 plus 1, 3. Jigsaw emoji. Here's why the solution works. Our stack-based algorithm handles this input perfectly. 2 push 2. 1 push 1. Plus pop 2 and 1 compute 2 plus 1 push 3. 3 push 3. Pop 3 and 3 compute 3 times 3 push 9. At the end, the stack contains a single value, 9. Highlight output box, 9. And that's exactly what our program outputs, 9. This matches the expected answer, so the test case passes successfully. White check mark emoji, wrap up. So, our implementation is correct. The algorithm successfully evaluates the reverse Polish notation expression by pushing numbers, applying operators when needed, and leaving the final result on the stack, efficient, accurate, and reliable. Now let's try another implement approach using solution 2. Line highlighted. Import operator. We import operator to use built-in math functions. Pause. Line highlighted. Class solution. We define the standard solution class. Pause. Line highlighted. Def eval RPN self, tokens. This method evaluates an RPN expression. Pause. Line highlighted. Ops equals. We map each operator, plus, / to a function, using a lambda for division to handle truncation. Pause. Line highlighted. Stack equals. We create a stack to hold numbers and results. Pause. Line highlighted. For token in tokens, we process each token in order. Pause. Line highlighted. If token in ops, if it's an operator, we apply it. pause. Line highlighted, b equals stack.pop, a equals stack.pop, we pop two operands, pause. Line highlighted, stack.append ops token a, b, we compute the result using the operator map and push it back, pause. Line highlighted, else, stack.append in token, if it's a number, we convert and push it, pause. Line highlighted, return stack 0, the final value on the stack is the answer. Pause. Time complexity, on. Space, on. And that's how this algorithm works. A clean operator map plus a simple stack to evaluate RPN efficiently. Highlight input box, tokens equals 2, 1, plus 3. Let's test our function using this input, 2, 1, plus 3. These tokens represent an arithmetic expression written in reverse Polish notation, where each operator applies to the two most recent numbers on the stack. Left magnifying glass emoji, what the input represents. This expression corresponds to the calculation. Push 2. Push 1. Apply plus becomes 3. Push 3. Apply becomes 9. So mathematically, it's the same as 2 plus 1, 3. Here's why the solution works. Our operator map version handles this very cleanly. 2 not an operator push 2. 1 push 1. Plus operator pop 1 and 2 compute 2 plus 1 equals 3 push 3. 3 push 3. Operator pop 3 and 3 compute 3 times 3 equals 9 push 9. At the end, the stack contains exactly one value, the final result. Highlight output box, 9 and that's exactly what our program outputs, 9. This confirms that our code is working correctly and passes the test case. Wrap up. So, our implementation is correct. The algorithm successfully evaluates the reverse Polish notation expression using a clean operator map and a stack, efficient, accurate, and reliable. Ever feel like arithmetic expressions get messy with all the parentheses and operator rules? Evaluate reverse Polish notation flips that chaos into clarity. With one clean stack pass, everything falls neatly into place. No precedence worries, no nested confusion. We're given tokens representing a mathematical expression in postfix form, numbers and operators in sequence. Our goal is to evaluate it and return the final integer result, with division that truncates toward 0. Conceptually, it's about understanding how stacks mirror computation order in a structured, step-by-step way. The beauty of RPN lies in its simplicity. As we scan tokens left to right, numbers are pushed onto a stack. When we hit an operator, we pop the top two numbers, apply the operation, and push the result back. No need for parentheses or operator precedence tables. The key detail: ensure division behaves like real integer truncation toward 0. Here's the logical plan. Initialize an empty stack. For each token, if it's a number, push it. If it's an operator, pop two numbers, right then left, compute, and push the result. At the end, the single value left on the stack is the final answer. We followed that flow precisely. One stack, one pass. The operations handled correctly, especially division truncation. The code ran smoothly on LeetCode without any errors. We validated the logic across multiple test cases, from simple additions to chained multiplications and mixed divisions. Each case matched the expected output. Consistent, correct, and efficient. The takeaway? Mastering stack-based evaluation isn't just about RPN, it's about learning to break problems into simple, repeatable actions. Once you see how order unfolds naturally through a stack, complex expressions become effortless to decode.